Good day, everyone. This is Grade Cove Mathematics CAP Syllabus. Today we're going to discuss Unit 1, Exponents and Surds. So, what are exponents? So, exponents are when, for example, we can have 4 is equals to 2 squared. So, an exponent is that power, the number on top. That's an exponent. Then a surd is a number, for example, square root of 2. It's a surd because it cannot be simplified into a fraction. So a surd is a number that a square root that cannot be simplified into a fraction. So for example, you can see 72. So what I'm just going to give you an overview of what you're going to be doing. So 72, if you simplify it, it's equals to 36 times 2 square root. Then you say square root of 36 times square root of 2. So we know that square root of 36 is equals to 6. So that's 6 root 2. So these are some of the aspects that you're going to be covering in this unit. Then for exponents, we are also going to look at the different types of products, divisions, how we do it. For example, this a to the power m and a to the power n. If there is a multiplication sign, it means we can add the powers. So that will be like m plus n, as you can see here. So for example, if you've got 2 squared times 2 to the power 3. So remember, one thing you have to notice, they should share the same base. You can see they are all on the base 2. So you add them up, so it becomes 2 plus 3. So it becomes 2 to the power 5 if you simplify it. So in other problems that I'm going to cover, it's also going to look at the solving equations for x. So in this example, so it's 4 to the power x plus 1 is equals to 32. So one of the tricks you should be able to notice is that 4 and 32, they can also be raised to the power of 2. So for example, we know that 4 is equals to 2 to the power 2, and 32 is equals to 2 to the power 5, because 2 times 2 is equals to 4, right? Times 2 is equals to 8, times 2 is equals to 16, right? Then times 2, 16 times 2 is equals to 32. So, in other words, we are saying 2 times 2 times 2 times 2 times 2 is equals to 32. So, this one is now simplified to 2 to the power 5 is equals to 32. So, now when we come back here now, maybe let me first delete this part so that you can see. So, now it becomes 4, you know that is 2 to the power 2 x plus 1 is equals to 2 to the power 5. So because they are sharing the same base, it means the exponents, which is 2x plus 1 in bracket, is equals to 5. So we can now say 2x plus 1 is equals to 5. So if you simplify now, it means 2 times x is equals to 2x. 2 times 1 is equals to 2 is equals to 5. Then you simplify. 2 is equals to 5 minus 2. Remember, when you put 2 on the other side, it becomes a negative. So you now have 2x is equals to 3. Divide both sides by 2. You get x over 2. So that's how we reach here. So these are the things that we're going to be covering in this section. So unit 1, these are the ideas which we are going to do. So let's go to the next one. So the learning outcomes. So we're gonna do conceptual knowledge, procedural fluency, and examination application. So under knowledge, conceptual knowledge, you're gonna classify numbers correctly, gonna distinguish rational, irrational, real and non-real values or numbers. Then we're gonna explain what makes a root a surd. I just gave you a preliminary overview. Then we're gonna also simplify surds and powers or exponents, rationalize denominators, use zero, negative, and fractional exponents. That's what we're gonna do as well. Then under examination, exam application, we're gonna solve exponential equations, solve equation involving surds, and also check answers after squaring. So what's gonna happen is like you must know the type, number type, then apply valid laws, whether exponent laws, surd laws, operations with multiplication and divisions and stuff like that. Then you justify the solution. So this is more like what we're gonna be doing under this unit 1. So these are the learning outcomes. So let's go to the number system. So in numbers, you should know that there are real numbers and non-real numbers. So real numbers are numbers that, in other words, we call they exist. Then non-real numbers, we can call them imaginary. They are just in the imaginary space which don't exist in the real world. For example, we can look into the real number set. So under real numbers, they are categorized into rational and irrational numbers. So under rational numbers, we look at integers, we look at whole numbers, and we look at natural numbers. So when you look at integers, we are looking at negative and positive numbers. So for example, for integers, we can have -2, -1, 0, 1, 2. So these are integers. So they are negative and positive whole numbers, including 0. Then we've got whole numbers. So whole numbers, they start from 0, 1, 2, 1, 2, 3. Then natural numbers, we are starting from 1, 2, 3, going forward. So if they ask you the difference between natural and whole numbers, you know that whole numbers include 0 and natural numbers don't include a 0, right? So remember also integers, we are talking about whole numbers, right? Whole numbers. Right, that's what we are talking about. So numbers that can be written as a fraction. So these are rational numbers. So these are numbers that can be written as a fraction. Rational numbers. So numbers that can be written as a fraction. So rational, they cannot be written as a fraction. So when we are looking into this now, irrational. So for example, we have an example, minus 11, square root of 11, it cannot be expressed as a fraction. For example, pi can also not be expressed as a fraction, because pi is a number that continues, it does not end. So I know that some people have expressed, if you go into your calculator and you type pi, it will give you a number like 3.14159265355 9. But doesn't mean this is the whole number. It continues. But because your calculator has got limited digits, it will display as far as it can go. But I know that some people in some textbooks they say pi is